Every second of every day, your body radiates heat. You are, right now, emitting roughly 100 watts of thermal energy into the air around you. That is the same output as a standard incandescent light bulb. Over the course of a single year, your body produces enough thermal energy to heat a small apartment for an entire winter. And every single watt of that energy is wasted. It dissipates into the air, absorbed by your clothes, your furniture, the walls around you. Gone. Unrecoverable. Or so you were told. In 1821, a physicist named Thomas Johann Seebeck made a discovery so dangerous to the global energy industry that it took nearly 2 centuries to suppress it. He found that when you join 2 different metals at their ends and apply heat to one side while keeping the other side cool, electrons flow. Electricity appears. No spinning turbines, no burning fuel, no moving parts whatsoever. Just heat on one side, cold on the other, and free electricity in between. He called it the thermoelectric effect. The power companies call it a threat. The device that exploits this principle is called a thermoelectric generator, or TEG. It is a flat ceramic square, roughly 40 millimeters wide and 4 millimeters thick. Inside are pairs of semiconductor materials, typically bismuth telluride, arranged in series. When a temperature difference exists across the module, from hot side to cold side, electrons migrate through the semiconductor couples and produce a voltage. One module costs between $2 and $5 online. That is the price of a cup of coffee, and it generates electricity from any heat source indefinitely, with zero maintenance and zero fuel cost. Here is the physics. The Seebeck coefficient measures how much voltage a material produces per degree of temperature difference. Bismuth telluride has a Seebeck coefficient of approximately 200 microvolts per Kelvin. That sounds small, but when you stack 127 semiconductor couples in series inside a single module, the voltages add up. A temperature difference of just 100 degrees Celsius across a standard TEG module produces roughly 4 to 5 volts and 2 to 3 watts of power. 3 modules wired in series produce 12 to 15 volts and 8 to 10 watts. That is enough to charge a smartphone, run LED lights, or power a radio continuously. Now here is where your body enters the equation. Your skin temperature averages about 33 degrees Celsius. The ambient air in a typical room is about 22 degrees Celsius. That is an 11-degree temperature differential. It doesn't sound like much. And with standard commercial TEGs, it isn't. A single module across 11 degrees produces maybe 20 to 40 milliwatts, barely enough to power a wristwatch. But researchers at MIT, the University of Colorado, and several labs in South Korea have developed flexible thermoelectric generators specifically designed for body heat harvesting. These devices use optimized materials with higher Seebeck coefficients and lower thermal conductivity. They can produce 20 to 50 microwatts per square centimeter from body heat alone. A wristband-sized device produces enough power to run a fitness tracker, a medical sensor, or a low-power radio transmitter. No battery, no charging, ever. The Pentagon has known about this since at least 2004. DARPA funded multiple programs to develop thermoelectric body heat harvesters for soldiers. The goal was to eliminate battery resupply in combat zones. A soldier carries an average of 70 pounds. Up to 20% of that weight is batteries. Thermoelectric body armor that converts the soldier's own heat into electricity for radios, GPS, and night vision would be a tactical revolution. The program was classified. The results were never published for civilian use. But here is the part they will never admit publicly. The physics works at any scale. You do not need a classified military program to harvest body heat. You need $2 and 10 minutes. Take a standard TEG module. Strap it to your wrist with a Velcro band. Put a small aluminum heat sink on the cold side. The heat sink allows the cold side to dissipate into the ambient air faster, maintaining the temperature differential. Connect the output to a boost converter, which costs about $1, that steps the voltage up to a usable 5 volts. You now have a body heat-powered USB charger. It will not charge your phone in an hour, but it will charge it in a day, using nothing but the heat your body was going to waste anyway. Now let us scale this up. Forget wristbands. Think about the places where serious temperature differentials already exist in your daily life. Your wood stove surface reaches 300 to 500 degrees Celsius. A TG module clamped between the stove surface and an aluminum heat sink has a temperature differential of 250 to 450 degrees. That is massive. At that differential, a single module produces 8 to 12 watts. 4 modules produce 32 to 48 watts. That runs a laptop. 8 modules produce 64 to 96 watts. That powers a small refrigerator. The total cost for an 8-module system is about $40. The electricity it produces over 20 years of winter use is worth thousands of dollars. Your car engine operates at 90 to 105 degrees Celsius. The exhaust manifold reaches 400 to 600 degrees. BMW, Ford, and Volkswagen have all prototyped thermoelectric exhaust heat recovery systems that generate 500 to 1,000 watts from waste engine heat. These systems were tested, proven effective, and then quietly shelved. The reason is simple economics. If your car generates its own supplemental electricity from waste heat, you need a smaller alternator. A smaller alternator means less drag on the engine. Less drag means better fuel economy. Better fuel economy means you buy less gasoline. The oil industry funds the automotive industry. The math is self-explanatory. Compost piles are another overlooked heat source. Aerobic decomposition generates temperatures of 55 to 70 degrees Celsius for weeks or months. A thermoelectric generator buried in a compost pile with a heat pipe extending to the cool surface can produce 3 to 5 watts continuously for the entire composting cycle. That is free electricity from garbage, literal garbage. The agricultural industry has known this for decades and has never commercialized it because the electricity is too cheap to meter. You cannot build a billing infrastructure around compost heat. Industrial waste heat is the biggest untapped energy source on the planet. According to the U.S. Department of Energy, American industry wastes roughly 20 to 50% of all energy consumed as rejected heat. That is the equivalent of 1/3 of total national electricity generation being dumped into the atmosphere as worthless thermal pollution. Thermoelectric generators could convert even a fraction of that waste into usable electricity. Several companies have tried. They have been bought, merged, or defunded within years of showing promising results. The pattern is consistent. Here is the complete body heat and small-scale TEG system you can build today for under $10. 1 TEG module, $3. 1 boost converter, $1, $50. 1 small lithium battery to store the charge, $4. Scrap aluminum for a heat sink, free. Velcro strap, free. Total investment, $8.50. This device strapped to your arm will produce a trickle charge from your body heat 24 hours a day. In 3 to 4 days, it will fully charge a small lithium battery. That battery can then charge your phone, power an emergency radio, or run a flashlight. For a wood stove system, the numbers get even more compelling. 4 TEG modules clamped to your stovepipe or stove surface, $16. 1 boost converter to step up to 12 volts, $2. 1 12-volt battery from a junkyard, $10 to $15. 1 small inverter, $12. Total system cost, around $45. This system silently generates 30 to 50 watts every time your stove is running. Over a winter season, that is enough to power all your LED lights, Charge all your devices and run a small fan to circulate warm air through your home. Zero electric bill for heating season lighting. The economics breakdown tells the real story. A grid connection costs the average American household $1,644 per year. Over 20 years, that is $32,880, not counting rate increases, which have averaged 2.5% annually. A $45 wood stove TEG system producing 40 watts for 6 months per year generates approximately 87 kilowatt-hours annually. At current grid rates of 16 cents per kilowatt-hour, that is $14 worth of electricity per year. So the system pays for itself in about 3 years. But here is the real value. When the grid goes down, your stove TEG system keeps working. During the 2021 Texas power crisis, 4.5 million homes lost electricity in freezing temperatures. People with wood stoves and thermoelectric generators had heat, light, and charged phones, while their neighbors froze in the dark. The thermoelectric effect is 203 years old. The materials are cheap. The physics is proven. The applications are obvious. And yet, the average person has never heard of a TEG module. That is not an accident. That is a market protection strategy executed over 2 centuries by industries that profit from your energy dependence. The coal industry, the natural gas industry, the nuclear industry, and the electric utility monopolies all share one common interest. You must remain a customer. The moment you generate your own electricity from waste heat, you become slightly less dependent. And slightly less dependent, multiplied by 130 million households, becomes an existential threat. The equation has not changed since 1821. Heat differential plus thermoelectric material equals free electricity. The only variable is whether you decide to build one. The materials cost $2. The physics is free. What heat source are you currently wasting?